Hi students, welcome back to the next session. In this session, we are going to discuss about different types of quantum numbers and their significance. Types of quantum numbers and their significance. Before we start quantum numbers, let us please, we should know about initially what is a quantum numbers. Numbers are useful to understand the complete arrangement of the electrons. To understand the complete arrangement of the electrons in an atom, the quantum numbers are useful. These quantum numbers are also useful to describe the position and energy of the electron. So, quantum numbers are useful to describe the complete arrangement of the electrons, their energy, and the position of the electron in a given atom. There are basically we have four types of quantum numbers. In that the first type of quantum number is called as principal quantum number. The first type of quantum number which we are going to discuss is principal quantum number. What is this principal quantum number? Principal quantum number is proposed by a scientist called as Niels Bohr. Niels Bohr proposed this quantum number and it is denoted by a letter N. It is represented or denoted or indicated by N. Okay, this N gives values as N is equal to, N denotes type of shell. N is equal to 1, 2, 3, 4, etc. You can also write N is equal to 1, nothing but a K shell. N is equal to 2 is called as L shell. N is equal to 3 is called as M shell and so on. Okay. So, this quantum number tells about, did you observe? As the N value is increasing, the size and energy of the shell also will increase. For example, this is the nucleus of a given atom. Now, if I take N is equal to 1, nothing but K shell. Now, if I go with the N is equal to 2, L shell. As N value is increasing, the size of the orbit or shell also will increase, and as well as the energy of the orbit also increases. N is equal to 1 K shell, the orbit of the shell is very much closer to the nucleus. The electron is present in this particular shell. The energy when the electron is revolving around the nucleus in this particular shell, the energy of the electron becomes lesser because it is very much closer to the nucleus, more attractive force. So by this we can understand that as the N value is increasing, the size and energy of the shell or orbit or energy level also increases. So the principal quantum number signifies about size and energy of the given shell or orbit, or simply energy level. The size and energy of the given shell or orbit also increases as the N value is increasing. It signifies in the board examination, sometimes he is asking, write the significance of different types of quantum numbers. In that you can write this point, which is a very important point. As the N value is increasing, the size and energy of the orbit also increases. Now, to find out the number of subshells in a given shell, we can able to use the formula. Okay, to find out the number of subshells present in a given shell, we can use the formula N. I will write very clearly on the board. To find out the number of shells in a subshells in a given shell, we can use the formula N. If I take N is equal to 1, N is equal to 1, first shell we know that the first shell contains how many number of subshells means only 1. Nothing but the first shell contains only S subshell. Okay, N is equal to 2. In the second shell we have 2 subshells, that is N is equal to 2 means 2 subshells, one is S, next is a P. If I take N is equal to 3, we have 3 subshells, S, P, D. 3 subshells are there, like that. As the N value is increasing, here in this case, if n is equal to 1, to find out the number of subshells in a given shell, we can use the formula n. Nothing but that is n is equal to 1, s subshell. N is equal to s and p, 2 subshells are there. N is equal to 3, 3 subshells are there. Now, if you want to find out the number of orbitals, the total number of orbitals in a given shell, we can use the formula total number of orbitals in a given shell. We can use the formula n square. Now I will rub this. Here I will write. So we have, for example, we can write n square. If I take n is equal to, substitute n is equal to 1 in this, 1 square means that is only 1. The number of orbitals is only s orbital. Only one orbital is there, that is s only. Okay. Now if I take n is equal to 2 in this, 2 square, how much? 4. So we have s orbital is there, and p, in p we are having 3 types are there, px, py, pz. So there is total 4 are there. 2 square, 4, 1 is s, next is px, py, pz. Now if I take n is equal to 3 in this, it will become 3 square, how much? 9. S is 1, in p, px, py, pz, in d 5 suborbitals are there. That is d orbitals 5 are there. dxy, dyz, dzx, dx square minus y square, dz square. Understood? Like this we can find out. Okay. I hope you all understood the explanation related to principal quantum number. I will repeat again. Okay. Next, after this principal quantum number, the another type of quantum number which we are going to discuss is called as that is azimuthal quantum number. Next type of quantum number we are going to discuss is azimuthal quantum number. Next one is azimuthal quantum number or angular momentum quantum number, or it can also be called as subsidiary quantum number. Azimuthal quantum number or angular momentum quantum number or subsidiary quantum number. This quantum number was proposed by a scientist called as Arnold Sommerfeld. FELD, Sommerfeld. Arnold Sommerfeld proposed this quantum number. It is denoted, represented or indicated by a letter L. It is represented by L. Represented by L. Okay. Next, this quantum number, this angular momentum quantum number or azimuthal quantum number or subsidiary quantum number gives values, integer values as L is equal to 0, 1, 2, 3, okay, 4, etc. up to n minus 1 values. Understood? N minus 1 value. The L value tells about type of subshell. The value of L gives rise to type of subshell. Okay. So if L is equal to 0, the subshell is S. If L is equal to 1, the type of subshell is P. If L is equal to 2, the type of subshell is D. If L is equal to 3, the type of subshell is F, and so on. So, sir, what does this quantum number signifies? This quantum number signifies about type of subshell and as well as the energy related to that. It tells about type of subshell. Okay. It tells about type of subshell, what type of subshell it has got. Okay. So next, we have, sir, L is equal to 0, S subshell, L is equal to 1, P subshell, L is equal to 2, D subshell, L is equal to 3, F shell. Okay, that is F subshell. So I will repeat again. Azimuthal quantum number or angular momentum quantum number or subsidiary quantum number was proposed by Arnold Sommerfeld It is represented by a letter L. L is equal to integer value starting from 0, 0, 1, 2, 3, 4, etc. up to n minus 1 value, because L value depends upon n value. If n is equal to 1, L is equal to 0. If n is equal to 2, L is equal to, now you can, if you want, I will write even that also. If n is equal to 1, if you substitute in the formula, L is equal to n minus 1. L is equal to 1 minus nothing but 0. The type of subshell is yes, as I mentioned already here. So, this azimuthal quantum number or angular momentum quantum number or subsidiary quantum number signifies, tells about type of subshell. What type of subshell? Okay. Next one is, next type of quantum number which we are going to discuss is magnetic quantum number. Next type of quantum number is magnetic quantum number. Next one, magnetic quantum number. It was proposed by magnetic quantum number was proposed by Landy. Landy proposed this quantum number. It is denoted or represented by ml or simply m. Okay. Now, this quantum number signifies about different orientation of atomic orbitals. Orientation of atomic orbitals tells about different orientations of the atomic orbitals. How the atomic orbitals will orient, I will explain that. Okay, and this quantum number gives values as, for a given L value, it gives a maximum of 2L plus 1 values. Nothing but the ml values depends upon, the magnetic quantum number values depends upon azimuthal quantum number values. For example, sir, we are not understanding this. Can you please explain clearly? Means, for a given L value, if L is equal to 0, how many ml values are possible? So, ml is equal to 2L plus 1. How many magnetic quantum number values are possible? For L is equal to 0, you know, according to azimuthal quantum number, L is equal to 0 means type of subshell is yes, you know that. Okay, if I take L is equal to 0 in this, it will become 2 into 0 plus 1, how much? That is 1. There is only one s orbital, only one orientation here, s orbital. Okay, next, if I take the value, L is equal to 1, if I write, if I substitute that L is equal to 1 in this formula of related to magnetic quantum number, 2L plus 1, how much? 2 into 1 plus 1, how much? 2 plus 1, how much? 3. Okay, L is equal to 1 means, you know, the type of subshell is P. There is a 3 orientations are possible for P orbital. You know that is P subshell, that is this is a Px. Okay, this is Y, this is X axis, and this is Z axis. Next orientation is that is Px, after that Py, this is Y axis, and this is X axis, this is Z axis, this is Py, and next orientation is Pz, that is Pz. We are having X, Y, and Z orbital, like that. So, as the L value is increasing, okay, if L is equal to 0 means only one orientation is possible. Okay, if L is equal to 2, 3 orientations are possible for a given atomic orbitals of P here, and if L is equal to 3, L is equal to 0, one orientation only, because we are getting only s orbital. Okay, L is equal to 1, we are getting a 3 orientation, that is a P orbitals, Px, Py, Pz, and if L is equal to 2, how many orientations are possible and which orbital will come means, which type of subshell will come means, that is a D subshell. Even I will write that if L is equal to 0, I explain, L is equal to 1, I explain, I will take L is equal to 2. If I substitute that in a formula, ml is equal to 2L plus 1, it will become 2 into 2 plus 1, how much? 4 plus 1, how much? 5. So, there is a possibility of 5 orientations of the atomic orbitals of D. We know that L is equal to 2 means D subshell, and 5 orientations are possible for d subshell containing, that is d orbitals. They are dxy, dyz, dzx, dx square minus y square, dz square, and the values will come. Sir, okay, that's okay. Then how these values will come means I will explain even that also. The values of the ML value starts from minimum to 0 and maximum L values. Minimum to maximum values. For a given L value, the number of ML values possible are 2L plus 1 indicated by. Now ML value starts from minimum to maximum. For example, for make you to understand, okay, in an easy way, I will explain with example. L is equal to 0 if I take ML is equal to formula 2L plus 1. If I substitute 2 into 0 plus 1, that is 1. That is 1. Only one orientation is possible for S subshell, that is only S orbital, that is only one orientation is possible. Understood? 2L plus 1, this is only 1. Now, if I take L is equal to 1, we are having the formula 2L plus 1. That is 2 into 1 plus 1. How much? 2 plus 1. How much? 3. You know, as usual, L is equal to 1 means subshell is that is a P. Now, P orbital, P subshell, and there is a different type of P orbitals, Px, Py, Pz. 3 orientations are possible. And the values, 3 orientations are possible. Try to understand. 3 orientations are possible. So here is, I am explaining ML values starts from -1, 0, plus 1. Okay. ML values -1, 0, plus 1. 3 there is a Px, Py, Pz orbital. Now if I take L is equal to 2, substitute in this. 2 into 2 plus 1, how much? 5. So L is equal to means the type of subshell is D. D can give a possible orientations of the d orbitals is 5. Okay, that is, now L is equal to 2 means I will take that 2 value in this minimum to maximum to write ML minus 2, next minimum value -1, 0, 1 and 2, that is plus 1 plus 2. Okay, we are having here type of the different d orbitals comes is dxy, dyz, dzx, dx square minus y square, dz square. Like this, the orientations are possible. Understood? So, magnetic quantum number was proposed by, who is the scientist? I already told, that is Arnold Lande. Okay, the scientist who proposed magnetic quantum number is Lande, and it tells about orientation of atomic orbitals in space. Okay, next, that is in the atom. Okay, next, the ML values depends upon L values. Okay, now if L is equal to 0 means, you know, according to Azimuthal quantum number, L is equal to 0 means type of subshell is yes. I explained clearly. If you have any doubts, you can comment in the comment section. Okay, next one, the other type of quantum number what we have is, next type of quantum number is a spin quantum number. Spin quantum number. Spin quantum number was proposed by Lenbeck and Goudsmith. Lenbeck and Goudsmith. Goudsmith proposed this quantum number, and it is represented by ms or simply s. This quantum number signifies about spinning of electrons. Spinning of electrons around their own axis. Spinning of electrons around their own axis. Okay. Now, the maximum number of electrons which can be accommodated in a given orbital is 2. For example, I am not telling about subshell. S maximum 2, P maximum 6 subshell, D subshell maximum 10. So in S there is no degenerate orbitals. There are no suborbitals here we are having. and in P we are having a Px, Py, Pz. So total of 6 electrons, each contains 2. I already explained in the previous when I explained about I think Pauli's exclusion principle. There I think so. Okay, next D we are having is dxy, dyz, dzx, dx square minus y square and dz square. So each containing 2 electrons. So I am telling about the number of electrons present in a given orbital. Minimum of everyone contains there is a 2 electrons. In P we are having 3 types are there px, py, pz, each containing 2 electrons. So in this particular s orbital, if I take s orbital, maximum 2 electrons only. Okay, so 2 electrons are there in this. For example, helium atomic number is 2, configuration is 1s2, 2 electrons are there, 2 electrons are there. So I will represent that electrons like this. One electron will spins in one direction, another electron is another direction. The electron is spinning in clockwise. An example, electron is there. If electron is spinning in clockwise direction, okay, the value of spin quantum number given here is plus half. And if the electron is spinning in anti-clockwise direction, the value is minus half. Okay, each orbital of a given subshell contains 2 electrons. I told you very clearly here, explained very clearly. So if I talk about other element like go with the beryllium, atomic number is 4. 1s2 is already done here. I'm talking about 2s2, 2 electrons are there. Okay, so in these 2 electrons, they are having anti-parallel spins. Anti means opposite. But they are parallel, but one is spinning in clockwise direction, another is in anti-clockwise direction. Understood? If the electron spins in clockwise direction, it gives represented by upward arrow, and the value is clockwise direction, and the value is plus half. If second electron is spinning in anti-clockwise direction, represented by downward arrow, anti-clockwise direction like this, and it is minus 2, minus half, sorry, 1 by minus 1 by 2. Understood? So this spin quantum number describes, signifies about the spinning of electrons around their own axis. Okay, so the spin quantum number values I will write very clearly on the board. The spin quantum number values are: the electron is spinning in clockwise direction represented by upward arrow. For better understanding, I am showing that this is a clockwise direction. Clockwise direction, upward arrow, and the value is plus half. Okay. If the electron is spinning in anti-clockwise direction, downward arrow, anti-clockwise means like this, you know that, and this is anti-clockwise. That is minus half is the value. Understood? I will explain that example of helium again. Okay, helium atomic number is 2, configuration is 1s2. We have 2 electrons are there. So these 2 electrons are present in s orbital. In that, one electron spins in clockwise, anti-parallel spins. One is spinning in clockwise, one is spinning anti-clockwise. Now upward arrow, we can determine, we can consider this one is spinning in clockwise direction. Downward arrow for another electron spinning in a anti-clockwise. This is a clockwise, this is anti-clockwise. And for this one is plus half, this is a minus half. Understood? Now if you are having an idea about different type of quantum numbers and their values, okay, then we can solve a few questions based on this particular concept, okay, which we are going to get in the board examination. For example, I will explain one board examination question, okay, which were given in the previous papers of board exams. So one question I will explain. The question is as follows: the quantum numbers of distinguished electron of an atom are as follows. The quantum number values were given as follows: n is equal to 3, L is equal to 0 was given, ML is 0 was given, and MS is plus half was given. Understood? The 4 quantum numbers of distinguished electron of an atom are as follows. The question is, the 4 quantum numbers of distinguished electron of an atom are as follows. The values were given, and after this is information skills question. It was given in 4 marks. Okay, and after that the questions are as follows. The questions were given like this. The first question is, write the outermost orbit of this element. So first question is, write the outermost orbit of this element. And the second question is, write the electronic configuration. Write the electronic, I am writing simply electronic configuration of this element. Next one, third one, write the atomic number of this element. Write the atomic number of this element. Next, the fourth question is valency of this element. Valency of this element. Now questions are like this. Now see, now first I have to solve the first question. What is that? Outermost orbit of this element is. Now I told you already, according to principal quantum number, n values tells about type of orbit, type of shell. Now n is equal to 3 means what orbit is it? This is a K, L, M orbit, nothing but third orbit. That is a third shell. That is M shell. Okay, n is equal to 3 we got. Now L is equal to 0 was given. Okay, outermost orbit of this element is third orbit, third shell, that is M shell. Write the electronic configuration of this element is saying. Now before we write the electronic configuration, L value was given is 0. I told you already. Okay, L is equal to 0 means what subshell will come? L is equal to 0 means S subshell will come. That thing, but L is equal to 0, the subshell is S. So we got some idea, 3S. Very good. Next, ML is also 0. Okay, L is equal to 0 and ML is 0. Here, according to this, ML value is 0. Nothing but 3S only. Okay, and in this, MS is plus half. So I will write plus half. First only one electron is representing, plus half means first electron if you consider, that is 3s1. Understood? So I will repeat again. I think most of you did not understand clearly about this. N is equal to 3 means third shell, third orbit. Okay, that is M shell. Number wise, this is third shell, third orbit, 3. L is equal to 0 means type of subshell is what? S. ML is equal to 0 means in S only. Okay, and next, because orientations are not possible, only one S orbital is there. S subshell, orbital orientation is not possible for that. Hence, I am writing the ML0 means as usual 3S. And here's given MS value is plus half. So, in S subshell, that is containing S orbital, 2 electrons are there maximum. One electron spins in clockwise, another is anti-clockwise. If first electron is spinning in clockwise direction, value is plus half. We know that. I told you already 3s1. I hope you guess the element. Okay. Write the electronic configuration of this element. The 3s1 is a last differentiating electron configuration here. And before that, we may have something that is 1s2, 2s2, 2p6. 1s2, 2s2, 2p6, 3s1. Okay. So write the atomic number of this element. Okay, electronic configuration we wrote. Electronic configuration we wrote. Atomic number of this element is count number of electrons. 2 plus 2 plus 6. 10 plus 1, 11. Atomic number is 11. Okay, I hope you guess the element. Okay, the element name is 11 atomic number. Element name is sodium. Latin name is natrium. And atomic number is 11. Element is sodium. And valency of this element. Last shell we are having only one electron. So valency of this element is 1. Valency is 1. I will write very clearly here. Valency is 1. And sodium, we can write even whether it is a metal or non-metal. Sodium is a metal. He did not ask. Sometimes he might be asking, okay, whether the element is a metal or non-metal. So I hope you all understood this explanation related to quantum numbers. This type of questions may come. So I hope you all understood my explanation. If you like my explanation, please comment, share and subscribe. Thank you.